Hello. As you will know, all of today's networks are based on Ethernet, from the consumer at home to the SME down the road to the large enterprise in the centre of town. But while Ethernet and new technologies such as SDN and NFV are taking data centre networks by storm, can the same magic work in the wide area? And can incumbent carriers afford the transition? We'll be talking to the people with all the answers. But first, let's pin down the roles of carrier Ethernet and the MEF in the development of NFV and SDN.
SDN and NFV, they both are great building blocks for the future of networking. And if you look at them, they all has to do with control and manage the network elements as well as their functions. But none of them has to do with deliver end-to-end services people actually buy and purchase. And that's where MEF come in. You know, we're delivering what we call lifecycle service orchestration, which is sitting on top of SDN and NFV to really orchestrate that services end to end. And that's what we're focusing on. So in order to deliver future of networking, the third network, you need LSO, lifecycle service orchestration, SDN, and NFV.
Thanks. So we've heard how SDN and NFV will fit into the wide area Ethernet network, but can this concept really fly? Here's the industry analyst's view.
Well, I think there's two different answers there. The first one, with NFV, I think there are definite business cases. There's an obvious need for it because there's the ability to centralize resources that otherwise are spread all throughout the network. So if I'm an operator and I have a bunch of routers out in the field that I need to manage, if I have to do a truck roll, that becomes very expensive. If I can prevent that with NFV by doing a centralized administration, I've saved money. So I think the business case is there. SDN is a little bit more difficult to figure out because bandwidth is always trying to pursue the cheapest way of getting to customers in between sites. Because of that, we end up in a situation like we may have done with asynchronous transfer mode back in the day, where ATM had switched virtual circuits, but in order to put those up, there was enough of a cost uplift involved that it became easier just to provide a lot of cheap capacity, which Ethernet ended up doing at the end of the day.
It can, although it needs to walk before it flies. What's happening right now with SDN, NFV, and a lot of next stage technologies is a careful assessment of what can be done both within the carriers and network operators. SDN and NFV has got huge potential there to be able to increase service agility, decrease time to value for service offerings. But also to be able to potentially open the door to better and more interesting integration with end customers. Carrier Ethernet has become a lingua franca for data interchange. With SDN and linkages with service offerings, you can now start to bring together new services that integrate with the end customers, the enterprises that are actually consuming these services in ways that give them more agility, more service complexity, continue to add value and increase stickiness of the services that are actually offered. The challenge in this space has always been a matter of, we come up with services like bandwidth on demand, and being able to engage the customer to consume that well and to be able to actually leverage all the capabilities has typically been difficult. Greater integration with the underlying infrastructure from the operator standpoint, that can start to provide some really interesting service opportunities for the future. And the MEF is a forum in which you can bring all these things together and actually start to work on some of these pre-standard opportunities to pull this together and deliver real functional, practical service capabilities.
And how are service providers approaching the implementation of SDN and NFV in the wide area network?
Well, we already are actually. Thankfully, my engineering team, unbeknownst to me, began with SDN deployment in 2011, and the reason they did that was because we were being difficult with them on HR. And our team intelligently discovered that SDN is a road first and foremost to capital savings and operational cost savings. It drives efficiencies. It assures that the network then intelligently manage itself in some components. And as SDN is evolving since 2010, 2011 to where it is now and where we envision it to go forward, SDN has now become a mainstream component of our deployment, first and foremost in our IP infrastructure, in order to assure that IP services, MPLS-based services, and very soon Ethernet over MPLS services will also be able to be delivered through an SDN environment. That's step one from our point of view. Step two is quite critical from our perspective to see how we can create SDN-based infrastructure not only on our own network but across partner networks. PCCW Global has championed for many years NNI relationships, network-to-network interconnects, to assure that our network can be delivered in a ubiquitous fashion to end users, not just from our own capitalized infrastructures, but through partner networks as well. If we're unable to do SDN with partner networks, we'll be limiting the value that it's meant to deliver to end users. And therefore, we're busy working through the parameters from a product point of view, from a legal point of view, from a commercial point of view, how SDN can be deployed from our network to the partner networks in servicing end users.
Carrier Ethernet is interesting because it's very well placed in an SDN world, particularly the implementation that we have at Tata, which is PBB based. PBB is not something that comes with its own control plane. So being able to bring in a control plane which is then unified with other elements in the network is a huge advantage for us, and we're very well placed to take benefit from that. So there's an immediate benefit from SDN and how we can provide it. We also see a lot of interest from customers about what we've ended up calling traffic engineering as a service. So this is something that allows customers to dynamically change not just bandwidth and things that we've traditionally talked about, but also network topologies to suit their requirement. And that requirement might be some sort of failover in anticipation of a big weather event or a surge in traffic or anything else, or it might be a forced one which has been brought on by some sort of natural disaster or a cable cut or some other activity. So I think SDN provides a lot of the tools that allow us to bring those kinds of things to market. NFV, where it relates particularly to Ethernet services, is a bit more problematic. A lot of the investment that has gone into NFV to date has been really around layer 3 functions. And so, of course, we're participating in all of those, looking at how we can virtualize CPE functions, virtualize security services, and the rest of it. And these are services, in fact, we've been providing in one form or another for some time. The question of how that then applies to layer 2 I find really interesting, and this is something that I've been speaking to both in panel sessions and also with my colleagues, and so an event like Gen 14 is very helpful for me to meet other people in the industry that I can talk about these positions, these questions, these unanswered pieces that we need, and to get also vendors thinking about how they meet our needs. So it could well be that, to tie it back to the SDN concept, that in the meantime potentially functions do need to be virtualized in order to support traffic engineering as a service type things. And so I need that innovation on the NFV side in order to be able to support the SDN rollout as well.
We're excited about the opportunity of it. I think some of the things near term we're looking at, think about the networking industry for the past 20 years at an edge perspective. We've typically deployed fairly expensive, highly intelligent edge equipment. And it's generally taken someone with a large amount of expertise to configure and implement it. As we think about network function virtualization, what we'd love to do is to be able to just ship out a low-cost piece of CPE to the site, then configure it centrally, so that means I don't have to have a highly skilled network technician out at the site. I can configure it centrally, deploy it, and just have a pair of smart hands implement it. I think as we're thinking about implementing thousands of sites, I think that architecture will yield some really true advantages for us. I mean, that's just one use case, but I think we're, again, just at the beginning in the way we're thinking about NFV, but I think that's a very valid use case that can provide our customers a better level of service and better functionality and more profitability for the service provider.
Yeah, Colt is one of the few carriers who has adopted the SDN platforms already for quite a while in the orchestration layer. And we are using these tools now to integrate multiple vendors which we have in our network. So like on the CPE side, there's a different hardware vendor used as in the node, and we are integrating this now quite successfully so that we are not vendor locked in with the software tools we used in the past. So that's quite successful, and we are looking forward to expand the whole implementation of SDN NFV to also the lifecycle operations. So when the service has been set up, so that afterwards also we are much more flexible in making changes and modifications to a live service.
SDN is this construct really that underpins the third network. It's the idea that the network will be programmable rather than static. It'll be driven by software rather than by manual patching. It'll be driven by automation rather than by configuration. That's really the underpinning of an agile network. So it's fundamental. NFV is the application of cloud compute methods, cloud storage methods, to networking problems. The two technologies operate hand in glove. There's no question that NFV requires SDN. There's no way you can offer these cloud-based virtualized functions unless you have an agile and flexible underpinning from the networking space as well. So the bottom line is, as far as we're concerned, this has been an inevitable part of the future network, going back to the very formation and foundation of our company. So we have always had this construct. It wasn't called SDN at the time. We've had a software model based on programmable networks from the very beginning. And we've also embraced the use of cloud-based technologies in the delivery of these software systems. It's the only way that you can build a scalable, distributed system for the 21st century. The old integration model that underpinned, the old ways of control, be that the old OSS approach adopted by the telecom companies, or the distributed BGP, GMPLS, MPLS style, are incapable really of addressing the predictability, security, and the performance demanded by this new generation of network application. So the bottom line is that it's all one system that's evolving together. The network has been lagging, but the network now has to catch up through techniques such as the third network, or SDN if you like. But also the telecom guys have to embrace cloud as part of their service offering, both from a control, but also from a forwarding path and network functions perspective. And what I would imagine will happen is that these worlds will just merge. NFV will be subsumed into a application delivery network. It'll become just another set of functions or services that run within this new exciting application network.
All networks need tools for management and monitoring, so the developers of those tools have a great insight into how new technologies such as SDN and NFV work. So how do they see the future for those technologies in the wide area network?
So SDN for operators, it is very promising, but it is still in a very early stage of adoption. And we see that NFV will be adopted much sooner than SDN because of the nature of what NFV can offer. It is going to sit in the customer's data center. But if you get a look at a telco environment, it is very complex, unlike a data center or an enterprise network. So SDN for telcos, it will take some more time, but we see a lot of our customers already looking at SDN. As part of our SDN WebNMS orchestration platform, we are trying to help our customers where their today's network is in a very siloed fashion, where they have both physically the network is in a siloed fashion and their monitoring of the network is silos, where they have multiple systems to monitor their own network. So our orchestration platform, what we do is it unifies the existing network, which need not necessarily be a SDN enabled network, but we help customers to prepare themselves to when they bring in SDN services. So the unification is a prerequisite to automation of SDN networks. So that is what we do. We focus on multi-vendor unification, where when the customer has multi-vendor environment and multi-layered environment, both from layer 2, layer 3, and also multi-technology. So customers have different technologies. Some part is optical, some part is microwave. So we unify the telco environment using our orchestration platform. And on the SDN part, we are integrating with the SDN controllers like Open Daylight controller, Floodlight controller, and even controllers from equipment vendors like Huawei's controllers, NTT's controllers. So when these controllers get deployed in our telco customers, our orchestration platform can seamlessly work with the controllers to do monitoring, management, and service assurance.
The Open Networking Foundation has been the champion for open software-defined networking since its formation in 2011. And more recently, we've been very focused on examining the needs that major operators have, which is not surprising given the other industry initiatives that have unfolded, namely the ETSI Network Functions Virtualization Industry Specification Group. They've actually approached the Open Networking Foundation to work together, which we were very receptive to. And they're looking at a very broad set of use cases that span many different segments of the network. And the Open Networking Foundation has responded by creating activities that are focused on optical networking, wireless networking, and then traditional wireline networking as well, access and related segments. And what we've done is we've looked at how we can extend Open Networking Foundation standards that were originally developed for the packet world, primarily for the data center, but also for some cloud providers as well, and be able to tailor that for the major carrier traditional telecommunications environment. And the types of use cases that we've seen, one of the major ones has been, how do you respond to the cloud? The impact of the cloud has been pervasive. The data center was the first place, but most operators were really not participating there until more recently. Where they were more interested is tying the data centers together. And that's where the Open Networking Foundation gets into the picture by providing a way in which to extend Open Networking Foundation standards to support data center interconnection, to support virtualizing the wide area network, to support private networks for large enterprise, which are using similar technologies and approaches, only instead of working with the carriers, they're actually providing their own limited scale networks, in some cases fairly large networks. And the Open Networking Foundation has spanned all of those areas. And what we found is that there is a real shift going on with the operator community who a couple of years ago, I'd say 2012, were very nervous about the implications of software-defined networking on their overall plans and networks. It was more of a 5 to 10 year activity, whereas now what we're seeing is, thanks to network functions virtualization and also the I would say the evolving thought process of many operators who are now beginning to look at the implications of software, we're seeing this as more of a near-term objective, not just a longer-term objective.
And finally, the systems vendors that have to make the kit that drive it all. What is their perception of their customers' needs when it comes to SDN and NFV?
Well, I think most of the customers are really thinking about the SDN and NFV in two different perceptions. One is, what is the real thing, or what are the problems they're trying to solve? I think one of the biggest problems today they have is the OpEx. They're still going through vertical integration of management and specific technologies. There is still a divergence in terms of how networks build. Require a lot of areas like network convergence in terms of different devices, different functions. The other part is how you empower the network with more intelligence to make sure that this programmability is viable across all endpoints. And obviously on top of it you have the orchestration, which means 3 elements which are important, and when our customers looking on those areas, they need to make sure eventually that if we're speaking about SDN NFV, first of all, what is what? SDN enables programmability and separation of control plane from data plane. NFV is more virtualization of the functions. I think each one of them sees a bit differently the use cases, the requirements, and I can get you into 2 examples. For example, data center interconnect, which eventually is speaking about bandwidth on demand from optical infrastructure, and this is really like a pure optical SDN. The other use case is application awareness. Orange Business, for example, we did a proof of concept, and this proof of concept was to identify how the network behaves, first of all, and what kind of application running on the network, and after that, to virtualize some functions like deep packet inspection to those endpoints and to verify what kind of traffic really running through the network, to understand the needs and actually build a business case to sell new revenue streams, because this is the reality. Everybody would like to get into new revenue streams with some new technology. So we're trying to solve a couple of problems, identify what is the virtual and what is real, and I think this is the stage of the industry.
As you see the rollout of SDN and NFV, there's a lot of questions of what is going to drive it. Is it a OpEx savings, or is it a CapEx, or is it about service innovation? And I've asked that particular question to my customers and got some really interesting responses. One was that if you're not looking at this holistically or strategically, you're not looking at it correctly. Another one I asked, well, how do you justify to your CTO, your CFO, that you want to spend money on some very forward-looking innovations that are going to drive service revenues down the road? And he said, well, if you have to ask that question and don't get the answer you need, you probably have the wrong CFO. Somebody else said that you really need to be looking at what your competitors are doing. So that says that the whole discussion is really strategic. All of these operators are having to reinvent themselves, and SDN, NFV, and carrier Ethernet are all key components of how they're going to do that reinvention.
So it's clear that there is a wave of support for SDN and NFV in the wide area network of the future, or indeed the wide area network of today. Wide area networking just got smarter.